afternoon, everyone. I'm Hannah Dorn. I am the marketing manager and an agronomist here at Ward Laboratories. And today we've got Dr. Nick Ward and Dr. Ray Ward for a discussion on plant analysis. So just a few things to get started. We want this to be very conversational and we want to make sure that we're answering the questions that you guys have. So feel free to use the chat box or the Q&A box to submit those questions, and we'll try and get to as many of them as we can. A little brief intro. Dr. Ray Ward and his wife Jolene founded the lab back in 1983, and Nick came on as the president of Ward Laboratories in 2015. So together combined, they've got several decades of experience with laboratory testing and specifically plant analysis. And so with that, we'll go ahead and get started. Let's just start off with a simple question. What is plant sampling?
Go ahead.
Okay. So plant sampling or plant analysis is just simply taking a plant part or a whole plant and then go ahead and digesting that and to analyze the mineral content, and then using that as a decision tool to either make a decision or diagnose a problem, something along those lines. But
sometimes it's called tissue testing. But we do not test the tissue as such, because when we receive the samples, we dry the samples to get rid of most of the moisture, and then we grind the sample after it's dried so that we get a representative sample for doing analysis.
Perfect. All right. We'll go into the next one. Why plant sampling? That's a big question and something that we've heard lots and lots of talk about this year, especially with the current status of input costs and things like that. So why should someone be interested in plant sampling this year?
Well, there's two reasons to do plant testing, is what I've always said. And one is to monitor the plants to see if the plants are using the nutrients that you applied in your fertilizer. And the second step is to diagnose problems. If you see something that's not abnormal growth in the field or discoloring, then take a plant sample analysis to determine if there's a deficiency or toxicity.
yeah, so yeah, that monitoring side, I think that's really what folks are going to want to focus on in the high fertilizer environment or high input cost environment we have today, is that if you are trying to run a tight ship on nutrient inputs, you can monitor the plants, during the season to make sure that you're still sufficient and have healthy plants. So I think that's kind of the main reason maybe to use it in a year like such. But I think that the diagnosing, I think that's successful for customers every year when they see something that doesn't look quite right.
And on the nitrogen side, with the capability of putting a lot of nitrogen through irrigation pivots, it's just, you can wait and see if you really need the nitrogen before you apply it.
All right. So next question, when should someone be taking a tissue sample? What is the proper timing?
Yeah, great. So I guess I'll start, and then I'll kind of preference that is that it's probably dependent on the crop that you're trying to sample. But in general, a general guideline would be you'd want the sample or the plants to be old enough to where they're being influenced by the soil that they're in. So for instance, if we talk about corn, it would be the most prevalent example, is that if you were to sample at a very early stage, V2 or 3, we know that a lot of that fertility of that young plant is still coming from the seed. Therefore, you might get some results that won't be necessarily indicative of what the plant's seeing on those early timings. A lot of the environmental conditions are determining how good that plant looks. So I guess the caution is to wait until that the plant is feeding off the soil it's in. I guess, does that make sense?
So I think so. And then for some crops, vegetable crops especially, sometimes you need to tweak fertility at a certain time to make the produce look as pleasable as possible for the grocery store. And so there's some of those kind of things that go on too. But the real early sampling is probably should be avoided or reduced quite a bit, and wait until the plants are really growing good. Like, you know, in corn, a V5, then it's already growing pretty good. So you can sample at that time. Not any earlier than that.
Right.
Yeah.
So then is there benefit in continuing to sample throughout the season as well?
Yeah, sampling throughout the season, and that's that monitoring aspect of where you can kind of track that nutrient content is at a level that's sufficient for proper growth, or if you start to drop and you're not having the necessary nutrition.
Yeah, and the older the plant, the more carbohydrates are in the plant, or cellulose and those kind of things. And so as the plants are developing, they get more carbon in the plant, so to speak, and the nutrient levels go down, the sufficient nutrient levels go down. So a nutrient level that you see at V5 on corn is going to be different than at V18. And I think, so the idea and the kind of plants that you're sampling, we want the most recently mature leaves in probably earlier in the season than later in the season. And of course, you do it earlier, then if you have a deficiency, you can put something on. If you wait too long, it's too late to really affect anything. So,
and I kind of to piggyback off that a little bit, and kind of the hint of what we're actually reporting on the plant analysis is that we're reporting either the percent of the mineral or the parts per million of the mineral. So it's just a standard, I guess, number, so to speak, that this is how much percent nitrogen is in the plant. This is how many part per million zinc is in the plant. Those are the kind of values that are reported. So, and that's
we report concentration in the plant, and then we have adequate levels, and then we can define low, and it's maybe too high of levels sometimes too.
So that segues really well into another question we get quite often, and that's, are my plant sample results tied to the yield of the field?
Yeah, so that's a great question. And then I guess to go to kind of preference that, I'd say let's all go back to and review our basic agronomy on the factors of yield. Is determined by, if we were to talk about corn, kernels per ear, ears per field, soybeans, beans per pod, pods per plant, plants per field, So yield is somewhat independent of the plant analysis that we're performing. Our goal is to try to identify or evaluate the nutrient status of the plant, and then the yield then comes based on those other factors. Is that clear enough? Yeah.
So, I think it's pretty clear to me anyways.
And so I think for a lot of our farmers that we deal with Ward Laboratories, we get folks that are growing very high irrigated corn yields in the 300 bushel range, as well as dryland farmers that are 85 bushel dryland corn in eastern Colorado. So really, when you think about each plant should have the same nutrition for it to be the best plant it can be, if you will. It's just that when you're in an irrigated environment, you don't have limitations of water. You also have a lot more plants per acre, but really the same amount of fertility that should be in your plant at a high yielding environment really should still be in your plant at a lower yielding environment as well. So.
Perfect. So we had a question come in. When is the best time to test for nitrates in an annual plant?
Testing for nitrates in an annual plant.
Would this be for toxicity for animals, or do they mean nitrogen in a plant? Because we normally don't test nitrate on, it'd be petioles on potatoes, sugar beets, and those kind of things, but we normally don't test nitrate except for certain specific crops.
He did type back in and he said yes for animals.
Okay. I guess when you take the samples near the time of be grazing or haying because as the plants grow, they'll continue to use nitrogen to make protein, use the nitrate to make protein. So if you have continuous growth, the nitrate level should drop in the plant if there's not excess nitrate in the soil. So you should wait until near the time you're going to harvest it or graze it before you take the sample.
So to kind of back that up too, then is like, what are a situation where you do get high nitrates in plants? You get overabundance of in nitrogen in the ground, or
when you have high nitrate in the soil or high manure application, or so to speak, high fertilizer application, when you got too much nitrate or nitrogen and then that goes to nitrate in the soil, then it accumulates in a plant. The plant's taking it up kind of in mass flow, and then the plant takes the nitrate and makes it into proteins and other plant parts. And if there's excess of nitrate, it just accumulates in the stalk. And probably the stalk part of the plant is higher in nitrate than the leaves.
so a big, robust answer there to that question.
All right, Ray.
I think he's okay.
Yeah.
He's getting excited about plant analysis.
Right.
All right, we've got some more questions coming in. And again, feel free to keep asking questions either in that question window or the chat. We want to make sure this is as useful for you as it can be. Let's talk about kind of a little different angle on this. Someone typed in, I soil test every year in November. It would be easy to do the Haney test and PLFA test at that time. Is there a downside to fall versus spring for those tests? And then I'll add on to that even further. Is there any advantage to in-season soil testing along with the plant analysis?
So okay, so first on the soil health analysis, kind of, and when to sample that, is that ideally we like to have those if you're using it for a nutrient management tool, in the fall or 3 or 4 weeks before planting is useful. But really, if you're looking at it from a evaluation of your soil health or your soil life, you really should wait till there are living roots in the field, or the plants are actively growing and do that sampling at that time. So I think that would be probably in season would be an ideal from that aspect. But from a nutrient standpoint, soil sampling in the spring or during a growing crop is a little bit of I guess a pickle you put it in, because the soil tests are correlated and calibrated to predict when a yield response could occur by adding a fertilizer nutrient. So it's kind of counterintuitive on in season, I guess.
Well, it's Nick, you kind of explained a little bit of the first of all, on when to take the soil samples, I say take it when you have time every year. Don't take it in the spring one time and the fall the next time. Try to pick a time when you can always sample at about the same time each year. And normally that's in the fall after harvest, but sometimes it's in the spring. And then when the plants are growing and evaluating the soil tests for fertility, and Nick just mentioned that that's the best time to take samples for soil health and microbial growth. And when the microbes are growing in the soil, they have a lot of these nutrients kind of in their bodies as they're growing and using them. And so a lot of times the soil test levels drop when the microbial activity picks up, because the microbes have these nutrients in their bodies. And so ideally you would want to take your fertility samples off season and biological samples in season. So
that makes sense. Yeah.
So a follow-up question came in regarding that. Wouldn't testing after fertilizing skew the results?
Yes. And especially nitrogen. The nitrate test, we're measuring water-soluble nitrate. And the fertilizer, if it's a dry or a liquid, and microbes that convert it to nitrate. In warm soil, it's pretty fast, and cool soil is slower, of course, but it shows the higher nitrate. Phosphorus, potassium, zinc, probably those are immobile nutrients. So when you put those on this in the soil, they attach to the soil surface as kind of a slow release or what I call surface nutrients. And so you can't detect those like you can nitrate and I should say sulfate. So, nitrate and sulfate, it works good. The fertilizer pick up for phosphorus, potassium, zinc, other elements. You can't really detect those from fertilizer application.
All right, let's switch gears here a little bit. We've had a couple questions about SAP analysis. So first of all, can you talk about the difference between SAP testing and tissue testing? And then we'll have a follow-up question after that.
I guess so. SAP analysis is a tool that's out there that is used by some, and not having complete background of the subject, I'd say the assumption is they're using something to squeeze or press the plant to analyze the liquid that might come out, versus a tissue analysis where we take the say a corn leaf. Let's just use a corn leaf as an example for both. In SAP analysis, we squeeze a corn leaf to get some sort of liquid to analyze. In a tissue analysis, we take the entire corn leaf and dry it down and digest it, so we get the total mineral content. So one, you're getting a total mineral content, and another, you're probably getting some sort of a solid, soluble, or maybe an extractable type nutrient. One of the big things that we always talk about, and Ray has always talked about on traditional tissue tests that we do, is that we have a good interpretive data on how to interpret plant analysis information. So if you have 3.5% nitrogen in your corn leaf, we're very comfortable in telling someone that is a sufficient range, versus some of the, and that's published not only in stuff that we do with the Ward Guide, but it's in university publications, it's in reference manuals and what have you. A lot of open source information, if you will, on what those numbers mean, versus some of the SAP analysis that might be a little less open source, if you will, or available for people to use and interpret a little bit differently. I guess anything to add to that?
I think so.
All right.
I think
Okay, good.
Nick covered it very well.
All right. Good questions. And there's lots more coming in. So this is great. We'll try to get through as many of them as we can. Okay, let's switch gears a little bit. How many times would you take plant analysis through the growing season on soybeans?
I guess my idea would be maybe to take a sample early bloom, and then as you get to R3 set, but there'll still be blooms, but the pods, the fourth node down from the top, it'd be 3/8 of an inch long. It's kind of R3 stage. So you'd have nutrients for developing as it's blooming, and then you could see if you have nutrients left to fill out the pods as the pods develop.
Yeah, so that's a great setup there. You kind of you determine when to take your samples based on when you might make a decision on some sort of an input or something. So like Ray just mentioned in that example, well, we know that these are the stages where we can influence maybe the yield by making sure our fertility is adequate. So those are the times we want to be sampling.
So to take the sample, the soybean plant, you take the top, what I call the top, the big trifoliates at the top of the plant or top of the canopy. So we say it's the most recently mature trifoliates. And when you take the trifoliates, you just grab the trifoliates and pull those. You don't include the petiole, just the trifoliates, and go to about 15 plants. So you'd have 45 leaflets. That would be a sample for submitting to the lab. Mm-hmm. And those would be placed in a paper bag, of course.
Yes. Okay, so then on a similar kind of different crop note, what extensive plant analysis have you had with cannabis, either for hemp or high THC?
Yeah, so we do some testing for that, and of course, once again, so what was the first part of that question though, Hannah?
Just what experience have we had with it?
Oh,
Well, we're running quite a few samples for cannabis and hemp, or whatever they call it both ways. I found in the plant analysis 4 handbook, I had to go to cannabis to find the leaf analysis to know what sufficient levels were. But we're doing quite a few of the tests.
Generally, I guess when folks are growing it for a THC use, you tend to have very high mineral content in the leaves. And then probably less so if it's for another purpose like a CBD or maybe a fiber, you probably don't have that high mineral concentration. But it's a very unique application. And once again, if it's a plant and it has leaves and we've got some interpretive values that we can apply to it, it's certainly usable data for the end user, I'd say. And I guess then, so I could piggyback off that real quick, Hannah, is that the number of plant samples or plant species that we could analyze for. I don't know, what is your list up to as far as?
I have about 100 plants in the computer. And of course, there's 1,000 more in that book.
So we do, for example, we will do a corn plant with someone right around central Nebraska here. These THC samples for cannabis growers. Sometimes we'll work with a homeowner that has a tree that's looking unhealthy, so they'll take leaves and we'll consult different guides for that. Fruit trees, other small grains,
lots of vegetables.
Lots of vegetables. So a little bit of everything. It's not just plant analysis isn't just for corn and soybeans. It can be. It's applicable for every plant variety out there.
Good question. So then kind of on that note, a little bit of a logistical question. How much estimated time is there between sampling the plant, getting it through the lab, and then the customer has results to make some decisions on fertilizing if that's applicable?
Well, it's taking the plant sample is fairly simple, I guess. You pick your sampling area and take the sample with our instructions and get that in the mail or some kind of shipping company. If you want it overnight, of course, that costs more, but you could get it in usually 2 or 3 days. And when we get real busy, it takes us 2 days to get the samples done. And when we get the analysis done, then Nick or I have to review the results. We don't have to, but we want to. And then they're marked, and then the computer can email them out. So if you got your samples taken, 2 days later we got them in, and then 2 days later we got them out, that's a 4-day turnaround time. So you got time then to get your fertilizer. If you need some fertilizer, get it purchased and get it on the plants.
All right. Let's go to kind of some more in-depth questions here. We've got one that says, how do environmental stresses affect the plant tissue analysis results? In other words, are deficiencies sometimes environmental stress related?
I think so. The one that always comes to mind was early in my career in South Dakota, when we had a dry summer. Normally potassium levels would be lower in the plants than it would be in the normal, more normal rainfall time period. So I know that one affects, and of course, as we get less water in the soil or drought, we have less nutrients that sometimes can come out. So and that's why potassium is that. Phosphorus probably drop. I'm not sure about phosphorus. Nitrogen may go the other way, where nitrate soluble, so they concentrate in the water, and so being more nitrate getting in the plant. So it could go either way. Normally, I would expect it goes lower.
Yeah.
With the stress.
Okay, we've got a couple questions here about wheat, so let's switch over to that. Let's tackle this one first. What stages of a wheat plant should be sampled, or at what stage should you be sampling for wheat?
We have tillering stage, joint stage, boot stage, and heading stage as our sampling as sampling interpretation. So we can start early, so to speak, early in season. Once we get full tiller out before joints, you can start at that time. Let us know what stage you're in so we can help on the interpretation. A lot of times I'm called to the login room to identify, is this stage 2, 3, or whatever it might be. So it's helpful when you list the stage when you send the sample in.
Yeah, and then to add on to that, then Hannah, when you're sampling wheat, you're to those earlier, the first 2 stages, the early stage, we're taking the whole plant for analysis. So you're just going to use a pair of scissors or shears to clip the plants off right above the soil surface, trying to make sure you don't get soil mixed in with that. And then also from a sample size, that young wheat, those young wheat plants are very high moisture content. So you really need a larger size sample, maybe the size of
like a big handful.
Big handful, softball size amount of wheat tissue. So when we dry it down, we still have an adequate amount to analyze. And then
So one thing I'll just say, when Nick said a sharp knife or I've said sharp, dirt or soil. And if you pull up a root and you get soil in this that contaminates the sample, and the soil is really high in iron compared to plants and some other things. So I really, and we do not wash the samples normally when they come in. We take them as they are. And sometimes in the bag, we don't see that there might be roots and soil in there. So be careful. And I'd say cut the plants off 1 inch above the ground surface. And then Nick, we have interpretation for full plants. Okay. For all the stages. I'd really prefer the whole plants to cut them off, and don't pull them out of the ground, cut them off, please.
And on that flag leaf, we do have an interpretation for wheat flag leaves. So if you wanted to just collect those, but once again, they're pretty small. So we'd ask for about 90 leaves there. Right.
Yeah. And why I found out that flag leaves might be better, but people get tired of pulling those little tiny leaves, and we don't get very big samples sometimes.
That brings up a kind of saying we have here at the lab: quality in, quality out. The best sample you can get us, the most accurate results we can get you back. So
right.
Sometimes it can be a little tedious and not so fun, but we do appreciate a good sample so that we can get you good information. We've got several more questions about wheat. Let's go to this one. On wheat, can I assume plant analysis be used to accurately determine if protein will be high or low?
I would say no.
You could use it as a proxy if you got good nitrogen content, but it all depends on that weather during that grain fill period.
Well, it depends. If you had a sample at heading time, you might be able to then, but earlier sampling, no.
Yeah.
Because talking to the Oklahoma State University recently, they're finding that an application of nitrogen fertilizer later in the season, it holds the protein where the yield stays the same, but the protein holds, where if you have the nitrogen on earlier, protein doesn't. So I don't understand quite what the plant is doing, but I would think we just want some nitrogen application on near heading time or at heading time to enhance the protein.
So if you think about what a wheat plant might be doing with tillers and a main plant or main head and tillers, that if you get that nitrogen on too early, it's going to try to put that energy towards producing more tillers. Whereas if you wait to that later stage, it's already decided that I'm going to allocate all my resources to maybe the main stem and maybe one additional tiller, and then you apply the nitrogen.
And I just thought of something then that they also said that when you put the nitrogen on later, you don't have the tillers, and your seeds and the mother heads are bigger and more dense, or the test weight's heavier. So that's probably enhances the protein also.
Mute button. Then a follow-up question. How about at boot stage on estimating low or high protein?
So at boot stage.
I think it would be, if you're low in nitrogen at boot stage, you know your protein is going to be low. And of course, if we recommended some nitrogen, or it said that you need nitrogen on at boot stage, then you're going to enhance the protein.
All right, we may have touched on this one briefly, but we'll revisit it just in case. Does wheat need to be out of dormancy for an accurate sample?
I would say yes.
Yeah.
Yes.
You want an actively growing plant, because if it's dormant, it's not going to reflect the true nutrition it's seen at that time. Its nutrition was based on what it was experiencing as it went into dormancy the previous fall.
And some people get moisture this time of year, so they probably leach out the nutrients out of the sample. Maybe in Kearney, Nebraska this year, it wouldn't make any difference, but
it's not us. We're not the ones getting moisture this year.
Yeah, right.
All right, I think we've got maybe one more wheat question here, and then we'll jump back over to some corn questions. You might need your whiteboard for this one. Here's the kind of situation. He says, I graze out wheat. I expect $160 per hundredweight for steers. Urea is $725 per ton. I am no-till. Will the plant analysis results tell me if it will pay to apply urea? And let me know if you need me to say any of those numbers again.
See, man, that is, I think if the nitrogen is really low, we know that the biomass is going to be lower. Now, if we have moisture, we could estimate that, but it would be difficult. I think right now it would be difficult for me to justify if $700 nitrogen would pay for itself, but I'd have to go back and study a little bit. When I was at Oklahoma State, man, a long time ago now, almost 50 years ago, we had a formula for how much dry matter took to produce a pound of beef. And I could go back and get that data and probably make an estimate for you.
We might have to follow up on that one. Okay, there was a question that came in that's not crop specific. So we'll tackle that one, and then we'll go back and get all these corn specific questions. Do you use any ratios of nutrients in the plant, for example, phosphorus to zinc, to interpret results?
Not currently.
No, and I've looked at some ratios on this on corn, but when we had some zinc deficiency, and then when I went and looked at the phosphorus zinc ratio, if the ratio got too wide, and the amount of deficient zinc plants and the amount of deficiency based on the ratio were about the same. And the question was, maybe we ought to be looking at that ratio, but right now we don't. And so that maybe that's something that Nick will have to do in the future. But
I think that's one thing we're going to try to tackle in some of our new plant analysis. I don't know if it's going to be done for this growing season, but the other one that comes to mind a lot, since we're just talking about winter wheat, is the nitrogen to sulfur ratio, and making sure that we get plenty of sulfur on. Because if we get too much nitrate accumulation in that young wheat, we get that ratio too wide, and then we show some sulfur deficiency stresses. So I think that's another one. And then the other one, the K to nitrogen ratio
and K to magnesium.
Yeah. So we're aware of those, but currently, with the reports get produced automated in a computer system. So that's something that we'd have to take time to program and add, but it's something that there is some definite validity to it. Yes, absolutely.
All right, so let's tackle some of these corn questions. First one, where do you acquire the baseline sufficiency levels for corn?
Well, I told some guys this morning right here, and we did a lot of research with corn and small grains when I was at South Dakota State in the 60s. And then J.B. Jones was at Ohio State. And of course, we had this North Central Soil Test Work Group. We studied plant analysis there. J.B. went to Georgia, and then he produced the soil plant analysis. The plant analysis handbook. And he published 4 different versions. Fourth version is an e-book. You have to buy it so it's on the computer, not pages. But Nick has a third version, and I know the authors. Some of the authors I know. So, and they have compiled a lot of data that agrees quite a bit with what I initially had from all the work I did at South Dakota State at that time. So there's those references is what I use. It's not going out in the field and trying to calibrate something currently. These are old standards I have.
Mute button again, darn it. To go along with that, looking at corn still, should the sufficiency level be higher in 350 bushel corn compared to 200 bushel corn? That's a common question we get a lot.
Well, it's one that I think about, and I asked Dr. Rich Ferguson at University of Nebraska one time, do you get higher yield by cramming more nutrients in a plant or by having more plants per acre? And he kind of thought about it a little bit and said, more plants per acre. And so if the nutrients are adequate on a plant, all we're doing is looking at that plant, or an average of 15 plants, so to speak. And we don't know how many are in there. Maybe that's only 15 plants in the acre. And nutrients are either adequate or deficient, or they could be excess. But so it's really difficult, I think, to say that plant's from 100 bushel corn or that plant's from 300 bushel corn if what we call sufficient. That I think it's the number of plants you have per acre is what makes that yield.
But if you are in the environment, I guess that's also why we have ranges. So, if we have, the sufficient range, well, you could be maybe on the higher end of sufficient range would be, more, I guess a better idea if you're in that super high yield environment versus maybe a more moderate yield area that is tougher to produce, then there's no reason to really have excess amount there. So I guess you could, there's some leniency there. I guess there's some play. You don't have to, it's not one specific value or nothing. I guess that's, which makes it somewhat helpful.
Hannah, the other thing I was thinking of is if you have too much of a nutrient in the plant, it might be detrimental to the plant and yield. And especially based on some of the ratios we talked about a while ago. But so I guess you really have to pay attention to that and try to, by having a higher yield, I think most of the time it's all the environmental conditions and the plant population.
Perfect. Are there any specific nutrients in corn that you often see at deficiency levels, and at what growth stage?
Well, the one that comes to mind right away for me is magnesium deficiency. I'm very curious about what's going on in the Great Plains states. We have a lot of low magnesium, and when we get samples more from the Corn Belt or east of us in Iowa and Minnesota and those kind of places, the magnesium is quite a bit higher. And it intrigues me, but I really don't know what to do about it. Now, we do have, well, I summarized some plant analysis in 2018. And I have the magnesium set at 0.15, below 0.15 is low. And it was 45% of our corn plant analysis was below 0.15. And it just, I don't know, and these are Nebraska samples, of course, but it's intriguing to me what's going on for sure.
I think the lack of liming, maybe with some dolomitic limestone, and then irrigation water, if it's low magnesium content, you just don't get that fertility, I guess, so to speak. So, but now is it detrimental to yield? I guess we've talked to guys that will demonstrate that the magnesium deficiency exists. They'll apply a rate of maybe 2 pounds of Epsom salts per acre, and the plants will look a lot greener and a lot healthier, but then we never really hear back of, they may look greener, so they don't want to leave a test strip. So we don't really have a baseline, but I think certainly it's something that when they apply, you do get the visual symptoms to disappear pretty rapidly.
Yeah, if you have a deficiency,
Yeah.
but I deficiency symptoms, but sometimes we don't see any deficiency symptoms either.
All right, and then on the topic of magnesium, what is the ratio of potassium to magnesium you like in a soil sample, and is it the same in a plant test?
They are not the same. I'll just answer that right away. In the plant, Bob Miller, he shared some research he did in the Corn Belt with studying potassium rates on corn, and he found that if you had a potassium to magnesium ratio of about 13 parts potassium, 1 part magnesium, that you got 45 bushel more corn than you do with a potassium magnesium ratio of 6 to 1. Now, we don't have anything from, if the potassium magnesium ratio is 30 to 1, we don't know what that means, but it seems like, and these are plots. So there's some environmental differences too. So it's just a kind of observation to make that in the soil, of course, the calcium magnesium ratio will be about 3 to 1, 3 calcium to 1 magnesium. So there's a big difference in those plant uptakes.
All right, this, I know, the darn mute button, you'd think I'd learn. This is kind of a fun question. So Ray, discuss your nutrient steps this year on your farm in light of your Haney results, nutrient costs, and overall soil health goals towards being a regen farm. So if you didn't know this, Ray actually has a farm himself that he's making the decisions on. So Ray, they're curious on what you're doing there.
Well, right at the point, thought right now is that I'm going to reduce my nitrogen probably about 30%. We're at, on some fields, 135 last year and 150 on others. And I'd like to get those down to about 110 this year if I can. And I got one field that yields are really poor on last year. And so I have up to 200 pounds of carryover in a grid sample field we did, and it may not get any nitrogen. My phosphorus tests in the fields, we've been broadcasting phosphorus and putting some on with the starter. So my idea is that we might go ahead and continue the starter, but we will not be broadcasting any phosphate or potash this year. And my philosophy on the recommendations that we've been giving you, that I always said I want to put phosphorus on without it being needed this year, just to maintain the soil test. So when we get a year like this, we could skip a year and not hurt ourselves. Now, if you've been on the border, if I don't put phosphorus on, I won't get my yield. Now you have to go ahead and continue to put on what you're putting on. But in my case, I'm going to be able to eliminate those this year and hopefully make a little money, as all farmers hope. And you know how little money is, maybe quite a bit, but.
All right, we've got about 15 minutes left. So if you've got any other questions, feel free to keep typing them in. This one isn't necessarily a specific question, but someone here wants to talk a little bit about sampling alfalfa for tissue or sampling alfalfa tissue. Can you talk about sample timing and kind of what to look for there?
Yeah, the guidelines that we have, the old guidelines anyway, was sample the top third of the plant in early bloom. Well, a lot of people don't wait that long to harvest alfalfa anymore. So you could say sample the top third of the plant in bud stage to get the analysis. Some guys want to harvest the hay, send the sample in for feed quality and also for nutrient analysis or sufficiency. And really the lower stems lower the values. And so our guidelines are based on the top third of a plant. And again, just clip the tops to get a big handful and be a sample. So randomly, it'd be nice to be able to stop 15 places to get some stems put together.
And then with alfalfa reduction, you're able to, even if you take that sample before your first cutting, now you can maybe apply some extra fertility for the second and third or even fourth cuttings as well. So you're able to.
That's a good point, Nick, because a lot of times people like to fertilize alfalfa after the first cutting because the first cutting gets pretty rank and you really don't need it for the first cutting, and then you can put the fertilizer on for the rest of the cuttings.
All right, here's an interesting question. There has been a tremendous talk about humates and molasses lately. Have you seen any increase in plant uptake with the use of these?
I don't recall ever seeing humate versus no humate samples come in. There may have been some, but I don't recall any differences. It's one of those things that we probably need more data on, but we just don't have it.
I guess I'd say that's kind of why our analysis is unbiased, because we don't, oftentimes we just go with the IDs that someone submitted. So if someone's doing their own trial, we don't necessarily know what they're doing. We just see they have 15 plant samples. So we could have been doing those samples and not known a single thing about it. But that's kind of some of the good things about being independent, is that we don't necessarily know some of those things, so we can't. We only know the information we're given, I guess. So if that makes sense.
Yep. I'll kind of add to that a little bit. We're oftentimes asked about, what are you seeing next year? And we're happy to share some of that information if we can, but it's always important just to submit your own sample. Yours isn't the same as the neighbors, and your practices are always different. So if you've got some questions, it's always best to just check what's going on your field. Another one here for corn. What would be a sufficient percentage of nitrogen for 300 bushel corn? Putting you on the spot.
Sufficient nitrogen?
Yeah, sufficient in.
At tasseling time, my standard is 2.7. It'll be above 2.7% nitrogen in the leaf, and this would be the leaf at the ear. And I always say the top ear, in case there's a couple of shoots out, you take the top shoot. If you're at just tasseling and the ear shoots aren't out yet, or just coming out, then it'd be 2.8. So somewhere, if you're above probably 3.2, you're probably excessive on the nitrogen. And again, that would be the plant health, and doesn't matter what the yield is. It depends on how many plants you have in the field, and the healthy plant would be in that 2.7 to 2.7 to 3.1 range would be ideal.
And then that would be independent of yield goal, correct?
Correct.
All right, here's a little different question than what we've had. Can you comment on raising bricks in alfalfa? Can we use tissue analysis to determine nutrient deficiencies that might be holding down our bricks levels?
The opposite, well, bricks is a sugar accumulated from photosynthesis. And if the plant is growing rapidly, the bricks level would probably be lower. And if you had a nutrient deficiency that was slowing growth, the bricks level might be higher. But I haven't, have you seen any data, Nick?
No, but
like that?
and then the other thing would be, you know, a sample early in the morning, after darkness, you've used up your excess sugars and energy to go through the nightfall. So you're going to have lower sugar to start the day than you would to end the day. So then, depending on what you wanted to look at from a nutrient standpoint, it's probably better to wait till maybe mid or late morning to sample in that situation.
I would say, yeah, probably either really late morning or after lunch.
Yeah.
Afternoon.
All right, well, for now, it looks like we've answered all of the plant questions so far, but these folks must know that you guys know a thing or two about soil, because a few soil questions have come in. This question can actually be translated to plant testing also, but does soil sampling soon after a rain majorly affect the results? And then same question for tissue sampling.
I think if it's super wet to try to take soil samples, the biggest concern I always have is, or how accurate are you on your depth control and actually collecting the full sample depth in the probe. So in muddy situations, you can get some compaction, or it's just a little too sloppy, and that could lead to some biased results. Also, then you get a lot of moisture in the sample, and if it warms up, then you could get some conditions that may turn out a lot of nitrate or something. So, you know, there's probably some other things that might not necessarily be related to the moisture, but more the conditions that it causes.
And so, the mobile nutrients like nitrate and sulfate, if it's a big rain, you have a potential for leaching or moving the nutrients down further in the soil. For the immobile nutrients like phosphorus, potassium, zinc, and those nutrients, it's not, the rain's not going to affect anything. It's more on what Nick was talking about with the sampling method, to make sure you get a good uniform sample.
And then on the plant analysis side of things, if you had waterlogged conditions or something in your plants, where you're not getting good root respiration, that could lead to probably some reduced uptake and might cause lower values. But and that's an environmental effect causing poor nutrient uptake, not necessarily deficiencies of the soil or a problem of the plant. It's the environment that's causing those problems.
So Nick, thanks for reminding me of that. I remind people that roots need oxygen to grow just like we do. And if you have you mentioned waterlogging condition or a compaction condition that limits the amount of oxygen in the soil, then you have less root growth, less nutrient uptake, and all those things. So sometimes if you have low nutrients, it might be a physical problem in the soil more than a nutrient problem. And we've kind of ignored that in this discussion, but it's something to always remember, is that your soil's got to be in good condition, that have a good nutrient uptake.
All right, we had another plant question come back in. We might have time for maybe one more after this one. What differences are you most likely to see on no-till corn on corn samples versus no-till corn on wheat or corn on soybean samples? Do you have any recommendation differences on this scenario? So we're back to talking about plants here, I believe.
I don't know that the nutrient levels, if Now, it all depends on how well the fertilization program is going on and what the nutrient level in the soil is. Corn on corn versus corn on wheat or something. I don't know. I think that the nutrient levels might be different in the soil, so there might be some differences, but it's not because it's corn on corn, I don't think.
You might have a little bit lower nitrogen to free nitrogen in the soil on a corn on corn scenario than a corn on soybean.
So then I just thought of some seedling diseases, those kind of things that would affect nutrient uptake. Which, if you have a monoculture, you're going to have more potential pest problems than you do in a rotation, which could affect the nutrient uptake.
Okay. And then another one here. Boy, I think these guys could keep you going all day.
Yeah. I know one that's not going to be able to stay much longer. So.
No, we're almost done. We'll wrap it up here in just a couple minutes. When it comes to the environmental effects on nutrient uptake, should we send in a soil sample taken at the same time as the tissue sample?
Well, from a laboratory management standpoint, we like to get more samples we get, the happier we are. But I would be inclined to do that. I just find that too many times the soil changes as you get the biological life going in the soil from plants growing, that it changes the soil test. And I just soon make my evaluation based on the plant analysis at this time during the growing season.
I guess it's one of those things that the more information you have, you get a little bit more power, I guess, with that knowledge, and you can make some maybe some different insights. So it's something that if the guy is willing to, save that information and try to monitor that from year to year, I think that'd be great for them. And it's one of those things that we can do the testing as long as people are willing to take the samples, and that they can often develop some insights that we don't particularly see because we don't have the time to look at the soil and the plant together and make comments and track that stuff. We gotta go on to the next sample and keep working on other things. So I think it could provide useful insights for somebody.
All right, we had two questions relating to foliar nutrition that I think we might be able to answer in one, and then we'll call that one the last one for today. If environmental conditions negatively affect tissue analysis, would you expect a yield benefit from applying foliar nutrition?
You tell me what's going to happen tomorrow, and I'll probably give you an answer. I don't know, Nick, maybe you had a better answer than that.
I guess, if you got poor environmental conditions, I guess you could, by applying nutrients foliar, it's just kind of a Band-Aid on the problem. You still have a plant that's struggling to grow because its root activity is not where it needs to be. So even though you might enhance mineral concentration in the plant, you're still not getting a healthy plant because you still don't have healthy roots. So I think you really have to, that's not the goal is to get a healthy plant, and to do that, you've got to have good root activity. So I think you could increase the tissue analysis, but are you really helping the plant or going to ensure that you get maximum yield? I don't think that's probably.
And that's right. If the weather gets, or the conditions change tomorrow, it'd be a positive, but if it doesn't change, then it'll be a negative. Good questions.
All right, well, that one takes us right up to about 2 o'clock. So we'll probably end it here. If you do have questions that weren't answered today, you can always email us, call us. Our contact information is on our website. We've got lots of folks here happy to help and happy to answer questions and navigate whatever kind of times we've got going on. So Nick and Ray, anything else to finish on?
Ray doesn't have anything, but I guess I just would sit and tell everyone I appreciate them spending the last hour with us, and encourage them. If they ever got questions, we got lots of resources on our website, and we look forward to help them with it, whatever they've got in the future.
Absolutely. All right. Thanks, everyone.